Anytime I start a new unit, gotta have the Dunkin' Donuts with you. Yeah, especially when it's really early in the morning and you just want to wake up. Anyway, Unit 1 in the books. Unit 2, here we go. This is a completely radical new unit. It's the Radicals unit. My name is Mr. Kraus. You can call me Mr. Answer Key for the next whatever long this takes. I don't know how long this video is. I won't know until I'm done, you know what I'm saying? If I keep talking and rambling, it's going to take forever. All right, so what we're going to do is take a look at the... Now remember, anytime I give you a function without any other stuff, this is called the parent function, right? Anytime. So notice it's just a y equals x, but because in this unit we're dealing with radicals, it's y equals the square root of x. Now kids, I'm going to use the word radical or square root almost interchangeably, okay? A radical is any radical and could be any power, but generally we're going to deal with square roots and cube roots. That's about it for the most part. So let's take a look. Let's take a look. Let's do it in our brain first. Let's just use our brain, right? So if I plug in a negative number, you can't take the square root of a negative number, can you? Right? You can't take, what? Oh, for those of you that are a little bit smart, you're going to find out, yes, we can, but not yet. We'll deal with that later in this unit. Okay, for now, we're going to deal with just positives because we want to stay positive. So let's say we plug in 0. What's the square root of 0? Well, the square root of 0 is 0. And then let's plug in 1. You take the square root of 1, you get 1. So 1, 1. Now what's the next nice number you know to take the square root of? Not 3, not 2, not 3, 4. Square root of 4. So I'm going to go 1, 2, 3, 4. The square root of 4 is 2. And the next nice square number, hopefully you understand, is 9. Oh, let's go to 9. 9, the square root of 9 is 3. So the graph of this function looks like this. We start at the origin, just like absolute value. We're going to start at the origin. It's our starting point. And we're going to go off and off forever. Square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, and it just keeps going slightly up. So this is the general shape of the parent function of a square root. Now, you should remember what the negative looks like. Oh, we're going to do this on the calculator. I forgot. We're going to take the dumb machine out. Say, hello, dumb machine. I'm back. Help me out. All right, dumb machine's going to come through with the square root. Now, to get the square root, it's this control squared button. You see the squared button right there? It's controlled square button. And it just hit X. And there it is. Looks like that. It's pretty. You can just keep going forever and ever and ever. Oops, and ever and ever. But that's kind of boring. So let me get out of that. I don't know. It's going to take me forever just to get it back. It'll be faster just to go like this. Oops. Crap. Credola. Oops. What? Okay, it may not have been faster, clearly. Square root of x. There it is. All right, so now what's going to happen? Well, you guys should remember, when we throw that negative in front, remember that is our reflection in or over the, all right, I'll work on my penmanship, x-axis. So if I type in a 1, I type in a 0, it's still 0. Nothing's changed there. But if I type in a positive 1, the square root of positive 1 is 1, but there's a negative out front, so it's negative. And then if I plug in a positive 4, the square root of 4 is 2, but there's a negative out front, so it's negative 2. And of course, negative 3. And then it goes like this. And that should come as no surprise to you that it looks like that, because there is your reflection over the x-axis. Now let's talk about domain and range for these things, because you know what? Everybody likes to talk about domain and range. Okay. So domain, remember, domain is how much did we go to the left, how much did we go to the right. Those are the domain ones, right? So we're going to deal with domain. To the left, well, we stop at 0. So 0 is the lowest value for domain. So, and we can equal 0, so we put a bracket, comma, and then you'll notice it goes forever and ever there. Anytime you have arrows on your graph, infinity. If there's solid points, please don't put infinity. It doesn't make any sense. For those of you that did that in the last test. That was a little weird. All right, now range. Range, I'll do in blue. How much did we go up? How much did we go down? Well, if you'll notice, this is the lowest y value. And again, the lowest y value is 0. And the highest y value goes, now it doesn't look like it, but it's going up and up and up and up slowly. So it'll go up forever and ever and ever. So it turns out they're exactly the same. Now this one's a little bit different. Domain's easy, but range ain't so much, right? Domain, we start here at 0 again, and we go in that direction. So it's bracket 0, comma, infinity. Range, however, You all hate range on this one. I don't know why everybody hates range on this one. So think about it. Range is how high did we go up, how low did we go up. And anytime you do domain and range, remember it's always low number on the left and high number or big number on the right. So the high number in this case is 0. The low number is it's going down forever and ever and ever. So the low number is going to be negative infinity. And the high number is 0. And I know that looks weird because you see that this is going down in this direction to negative infinity. And you're like, that's an 8, by the way. It should be probably infinity. And it's on the right. So you're like, oh, I should put it on the right. That's not how it works. That's not how it works. What is the low number? What is the high number? Make sure you put them in the right spot. Negative infinity can never go on the left. Ever, 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 ever. Okay, now we're going to move it. This is the same as the absolute value. It's the same as the work we did on the linear functions. Same. So, notice what happened here. We subtracted 3 on the inside of the radical. Now, if you subtract 3 on the inside of the radical, lo and behold, look at that. It just goes to the right 3. There's no difference. Now, remember, the point here is where we start. I should be doing this in like hot pink. This is the point where we start. And normally it looks like this, but notice this start point got moved 3 units to the right. So that's what's going on here. Now, if we talk about domain and range, domain for this one, now the new starting point is 3 because it moved 3 units to the right, but it's still going up forever. Range didn't change. At least in this case, the range didn't change because the lowest y value for the range is still 0, right? And then it goes up forever and ever and ever to positive infinity. All right, let's take a look at this one. This one's a little different. We like to call this Ronco. Just a little different. Just kidding, Ronco. Nice job on that last test, kiddo. All right, so here we got the minus 3. So once again, we're going to the right 3, and then we're going to go up 4. Up 4. And there's my new starting point. Again, there was my starting point, right 3, up 4. Well, notice on the inside, it's backwards. Right 3, up 4. Domain is the same as the last one. We're going to start at 3, and we're going to go in forever and ever to the right. Range is starting at 4 and going forever and ever up. All right, here we go. Let's go see what we got now. This is just evaluating. So, guys, I'm really struggling with this a little bit because I thought this should be a really simple thing, and some of you are struggling with it, some of you aren't. The x value, when I say f of 4, the x value is 4. What I'm looking for is the y value, otherwise known as the f of x. So you're just going to plug 4 in. So f of 4 is equal to the square root of 4, which is 2. That's the answer. G of 9, 2 numbers I have a hard time making. I don't know why. G of 9 is equal to, now wait a second, we got this negative in the front, so we don't want to forget about that. Negative square root of 9. Well, everybody knows the square root of 9 is 3. Okay, not everybody. Most people know that. So if the square root of 9 is 3, then we got the negative. The answer is negative 3. And then this one, h of 3, just simply plug in a 3. 3 minus 3. That's the square root of 0, which everybody knows is just 0. For those of you that don't know it, it's 2020. We wear a mask every day, all day long. It's weird. If it's 2021 and we're not wearing masks and you're watching this video, lucky you. Because 2021 or 2020 was a little rough. So I need to keep drinking water just to stay hydrated. All right, let's see what we're doing here. So let's check this out. We're going to put a 2 in front. Now, we talked about before that when we put a 2 in front of the absolute value or a 3 in front of that absolute value, we talked about the fact that it got steeper. I want to start using more math terminology. What's going on is the rate of change is going on. This is a dilation factor 2. Now, talking about steep and not steep when you're looking at an absolute value, it's hard to see it a little bit more. But what I want you to know is the rate of change is going up. It's going up faster. So the rate of change is speeding up. So you'll notice that normally I would put in 1, right? If this wasn't here, the square root of 1 would be 1. The square root of 4 would be 2. The square root of 9 would be 3. But what are we doing to these? We're dilating it by a factor of 2. In other words, you're just multiplying by 2. So it normally would be 1, but now it's 2. It normally would, didn't even make it, 1, 2, 3, 4. This is 4. Normally would be here, but now it's dilated by a factor of c. Notice it's going up steeper. It's got a faster or higher average rate of change. And then this is 3, and this is going to go up to 6. All right, so the domain and range actually don't change on this one. It's 0 to infinity and 0 to infinity. It's just getting there a little quicker because of the 2. Now, this is a little odd. Well, let's go back. We'll answer these questions real quick. Is k of x a function? It absolutely is a function. Is it a one-to-one function? Yes, it is absolutely a function, a one-to-one function. So some of you, when I asked about one-to-one or whether or not the inverse was a function, you told me it was vertical line test. And first of all, I don't want to see that. If it's a one-to-one function, then it does pass the vertical and horizontal line test, the horizontal line test being the more important one in this case. But, yeah, it's just in order for it to be a one-to-one function, it has to pass both the vertical and horizontal line tests. In other words, every x has only one y, and every y only has one x. And then that would make the inverse of this a function, and we'll talk about that at some point. Now, this is a little funky, little cray-cray. What happens when you put a negative on the inside? That's weird. Negative on the inside. Now, I'm going to tell you right now, we're really not going to deal with this much. But a negative on the inside, a negative on the outside is a reflection over the x-axis. A negative on the inside is actually a reflection over the y-axis in this case. And again, we're not going to deal too much with this, but it's a reflection over the y-axis. So you'll notice it should be going in this direction, but it flipped over. And it's steeper. That's all there is to that. So what's the domain on this one? Now this one's going to be a little weird, right? Remember, domain is left and right. Isn't this the rightmost number? So that has to go on the right. What's the leftmost number? Well, that would be negative infinity. Now range, isn't this the lowest number right here? That would be 0. And it goes forever and ever up, so up to infinity. Yes and yes, it is a one-to-one function, or it is a function, and of course it is a one-to-one function. So that's square roots. That's the parent function of square roots and the transformations that you'll see on a square root. And it's almost exactly the same as absolute value. You just have to know the shape. You just have to know the shape. Now the good news is the number sign helps you out a little bit there, so that's okay. All right. So now you're going to notice. Let me zoom in real quick. Didn't do a good job zooming. You see this right here? Now we're going to do this. This is a cube root. This is a cube root. So this would be the parent function of a cube root because the only thing it has is y and x. No adding of something, no subtracting of something, no adding on the inside, no adding on the outside, no adding, multiplying, no negatives. It's just a straight up cube root of x. Now, some of you are not very good at your perfect cubes. Actually, I would say most of you are not. But the good news is in a couple of days, we will be working on those. So I'm going to help you. We're going to start here at 0. Oh my gosh. So the absolute value starts at the origin. The square root function starts at the origin. The cube root starts at the origin. Fantastic. Now, the first perfect cube is 1. Why? Because 1 times 1 times 1 is 1. So if I took the cube root of 1, I would get 1. All right, now here comes the one where everybody messes up. 2 times 2 times 2 is not 6. It's 8. It's 2 times 2 is 4 times 2 is 8. So 8 is the next perfect cube. So we go over here 8, and the cube root of 8 is 2. Here's what kids forget. You can take the cube root of negatives. In fact, you can take the odd root of any negative. So we're going to take the cube root. So first cube root that's negative is negative 1, because negative 1 times negative 1 times negative 1 is negative 1. Negative 1 times negative 1 is 1. Times negative 1 is negative 1. That's a lot of negative 1s. So the first cube root of negative 1 is negative 1. And again, of course, the next cube root is negative 2 times negative 2 times negative 2. Remember, an odd number of negatives is negative. So the cube root of negative 8 is negative 2. So here's kind of like how this one looks. Comes in here, kind of makes a little squiggle, and it goes on forever and ever and ever. Now, the domain and range should be relatively simple for this, because you notice it's going forever and ever left and right, and you'll notice it's going forever and ever left and down. So domain and range for the cube root function is pretty straightforward. It's just negative infinity to positive infinity, and the range is negative infinity to positive infinity. All right, let's take a look at whether or not this is a one-to-one function. You'll notice that, in fact, it is a one-to-one function. So yes, well, it's a function, obviously. Passes the vertical line test. It is a one-to-one function. Yes. It passes the vertical and horizontal line test. We don't even talk about one-to-one if it's not a function. And is it even, odd, or neither? Interesting. So if you've got your paper in front of you, and you could take this thing and just turn it upside down. Go ahead and do that. Turn it upside down. Is it the exact same picture? Oh, yeah. So if that is, remember, that is the test for an odd function. So this is a odd function. All right. I don't know where my mouse. Okay, let's go talk about this one. So this one's going in the opposite direction. We've got a negative. Now remember, the negative in the front is a reflection over the x-axis. Now some of you might be thinking, wait a second, it was on the right, now it's on the left. Well, no, what it was up here, and now it's down here. So we're doing a lot on this one. We're going to reflect it in the x-axis. We're going to dilate it by a factor of 3. So normally the cube root of 1 is 1. But now we're going to multiply it by negative 3, so that's down here at 1. That point right here would be 1, negative 3. Now the next perfect cube is 8. The cube root of 8 is 2. So I'll go to 8. 1, 2, 3, 4, 5, 6, 7. I go to 8 here. And normally I would go down 2 if there was just the negative in front. Or normally I'd go up 2, but now the negative in front we're going to go down 2. But we got to multiply by 3 as well, so we're going to go down here to 8, negative 6. And I know that's right behind my big, huge melon. So I'll move that over. So that's 8, negative 6. So notice it's coming down. Now, okay, and then this way, if you plug in negative 1, the cube root of negative 1 is negative 1, but multiply by negative 3, and you get positive 3. And then 8 would be positive 6. So this is negative 1, positive 3, and negative 8, positive 6. We're going to graph these on the calculator because I want to show you how to, well, hold on. Let's talk about range. Domain and range, same. Negative infinity to positive infinity. Range, negative infinity to positive infinity. Now, here's where I want to make sure you understand something. I'm going to blow this up as much as I can. It's a little bit out of focus, but this is a function. Be very careful. Don't overthink this too much. This is getting closer and closer and closer and closer and closer and closer. It only hits the y-axis right here. Right? It's getting closer and closer. I'll try to show you that on the graph on the calculator when we see it. And then it starts becoming, so there's like a little teeny tiny gap in between the y-axis and this. So it does pass the vertical line test. And of course it passes the horizontal line test. So yes, it's a function. Yes, it's a one-to-one function. And it's odd. Obviously, if you turn your paper upside down. All right, so let's go take a look at this thing graphically real quick. Where's my graphing calculator? There she is. Nope, that's not it. What am I looking at? Oh, this one. Jeez. All right, so let me get rid of it. Free, fresh toilet bowl. And we're going to freeze. All right, so cube root. How do I get cube root? So we're going to come over here. Do you see this caret button right here? This caret. I got to get my mouse pointer to have a yellow mark on it. I'm going to do that. So we got a caret button right here. That's for any power. Cube root. Cubed, square, cubed, fourth root, fifth root, sixth root. if we want to root, we hit control that. So control that. And you'll notice we get a gray box here. Anytime you have a gray box, that's optional. But in this case, we want to take the cube root of x. And there's that. That should come as no surprise. But I want to show you the cube root of this. I want to show you the second one that we did there. And now we put a -3 out front. So I'm going to put a -3 out front. Now, it looks like it's going to fail the vertical line test right here. It really does. But let me change the window from -1 to 1. Oh, it's hard to see. Well, let me see. I thought I could. Well, I can't even zoom in anymore. Maybe I'll make this 0.1 and make this -0.1. It's still hard to see, but you'll notice it just keeps getting closer and closer. Trust me when I tell you it passes the vertical line test. Okay? So we got, for every x, we got one y. Oops. So, yes, 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 yes. All right. Got to pause for a second. All righty. Got to get some more water. Let's talk about these. I don't know why I didn't write f of x here. I like f of x better anyway. All right, f of x. So, what is this? Oh, please, this is a mistake. I apologize. This is a little bit of cut and paste mistake. Put this negative on the outside. Sorry about that. Put this negative on the outside. Because we know this, just like before, is a reflection in the x-axis. The A, come as no surprise, the A is a dilation of factor A. Now, pretending like this doesn't exist anymore because we moved it, we've just got a movement here. Where are we going? We're going to the left or right, and I apologize, I should have said translation. So a translation left or right, don't forget that for left and right, it's backwards. So if I'm subtracting, we're going to the right. If I'm adding, we're going to the left. Same as the absolute value. I told you we're going to be doing a lot of the same stuff. And this, of course, is a translation up or down, and this one's normal. Now, we won't be dealing, and the same is true with the cube root. I don't know why I have that negative on the inside. I really don't deal much with the negatives on the inside. Put the negative on the outside. These are all going to be the same thing. Same exact thing. Reflection in the x-axis. Dilation. Translation left and right. Translation up and down. If I do put a negative on the inside, which I'm not going to test on, I just want you to be aware of that. That will be a reflection over the y-axis, but you're not going to be responsible for that. So let's see what happens. This is a square root. Now, one of the things you got to get good at, even if you don't have a calculator, because you can graph this in 2 seconds if you don't have a calculator, even if you don't have a calculator, is the square root function looks like that. So anytime I see a square root, I know I'm going to draw something like this because this is the parent function. Get used to that. You're going to have to know what all the parent functions look like. A line, an absolute value, a parabola, a square root, a cube root, so on and so forth. Okay, so where are we going? I'm going to deal with the dilation in a minute. We are going to the right 3. So normally we would be here. This is where we normally start. But now we're going to move to the right 3. 1, 2, 3. And we're going to move up 2. Now don't do this, but that's what it's going to look. But it's going to look something like this when I'm done. Because this is the parent function, it's going to look something like that. Now, it's not like that though. So, I'm going to do this. Don't do this just yet, but watch what I'm doing. Normally with a square root function, we would go to the right 1 and up 1, right? Because if I put a 4 in there, what's 4 minus 3? 1. Square root of 1 is 1. 1 plus 2 is 3. Notice I'm at 3, right? 3. So you're going to find out with square roots, you go right 1, up 1, right 4, up 2, right 9, up 3. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So normally I would go to the right one and up one. Normally I'd go to the right 1, 2, 3, 4 and up 1, 2. And then the next one I'd go 8. 1, 2, 3, 4, 5, 6, 7. It would be somewhere around here. And not 8, 9, excuse me, 9, square root 9, and I will go up 3. So this is normally what the square root would look like. But we've got a dilation. So I've got to take each of those and multiply by 2. So instead of going up 1, we're going to go up 2. Instead of going up 2, we're going to go up 4. And instead of going up 3, we're going to go up 6. Normally I don't graph on the outside, but it gives me an idea of where to shoot for. So you don't go like this, right? You got to remember square root is going to go like that. And doing those ones off sometimes helps a little bit. Now, are you going to have to memorize that? Not really. I mean, those of you that are really good at math, you should get a pretty good handle of what that means. But for most of us, I mean, that's fine. It doesn't matter to me. We're going to go square root, so control x squared. Oops. Control x squared. So, we forgot the 2 out front, so I'll put the 2 out front. 2x minus 3 on the outside would go plus 2. Boom, there it is. Now, why did I say you don't have to memorize it? Because we can always go to the control table and look. Oh, yeah. Oh, remember, look, we got undefined because that turns it negative. So there's our first starting point, 3, 2. 3, 2, 4, 4. And then we go down here to... Did I pipe that in right? 3, 2, 4, 4. Oh, yeah, 4, 4. And then 7, 6. And the next one's going to be 12, 8. Now, why is it 12 and not 9? Well, what is 12 minus 3? What is 12 minus 3? Well, that would be 9. Oh, the square root of 9. What is 7 minus 3? Oh, that would be 4, square root of 4. And that's why it's 7 and it's 4. 4 was a little bit throwing me off, but there we go. So you can just plot the points on there. Oh, to state the domain and range. So domain starts at 3, goes forever. What's the starting y value, right? There's only 2 times you're going to pluck off y values. Range, min, and max. So this starts at 2 and goes up forever. All right, here we go. Cube roots. So where are we going? We're going to the right 4. 1, 2, 3, 4. We're not going up and down at all. We're just going to the right 4. Now, normally the cubes, because we're going to go cubes, we've got to remember we're going to go right and left, or left and right, left and right. So, we're going to go by 1, and then by 8, and then by so on. So, if I go to the right one, I would normally go up 1. If I go to the left one, I would normally go down 1. Now, the next one's going to be hard to see because the next perfect cube is 8. So 1, 2, 3, 4, 5, 6, 7, 8. It would be around here. Cube root of 8 is 2. So it would be around here. And then for the other one, we'll go to the left 8. Now remember, these aren't the points that we have because I believe this graph has a dilation. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So it would probably be there. But because we have the dilation of 2, we got to take each one of those and multiply it by 2. In other words, double its distance. So instead of being here, we're going to go up here. Instead of being here, we're going to double it and go up to 4. Instead of being at 1, we're going to go down to 2. And instead of being at negative 2, we're going to go down to negative 4. Now, the next perfect cube is 27. So you'll never graph more than 1 or 8. Or 0, 1, and 8. It's not that hard to do. So be careful here. It's going to look something like this. You come in and you go out like that. Sorry, it's really hard to do on the paper, but that's what it looks like. Obviously, the domain is forever and ever left. Let me get that. What the heck? There we go. So obviously, domain, negative infinity to positive infinity. And the range, negative infinity to positive infinity. Up and down forever, left and right forever. All right, let's keep going. We're almost done. Average rate of change over an interval. That's just slope. Now, So it's going to be a little bit different. Now for square or for lines and for absolute values, the linear unit we just finished, it was just the slope. That's not going to be the same because how do I take the slope of the line that's a curve? That doesn't make any sense. But we're going to use the same formula, slope formula, and you'll see how this works in a second. Please, people, like 5 of you put X's on top. It's Y's on top, X's on bottom. Now, if you want, put the 2's here and the 2 here and the 1 here and the 1 here. Right? It's the change in Y's over the change in X's. Everybody should remember that. All right, so let's talk about this absolute value function. Or excuse me, this radical function here. These are the domain that I want you to work in. I only want you to work in this domain. So we need to, and I should get really in the habit of calling these f of x. I want to find out what is f of 3. I want to figure out what is f of 7. In other words, we're going to plug in 3 and we're going to plug in 7 because we need to get the y values. Because remember, slope is a change in y's over change in x's. Right now, I have 2 x values. You got to remember that. Every time I give you an interval like that, I'm giving you the domain. I'm giving you the x values to work with. You got to figure out what are these y values. That's our goal. What are those y values? All right, we just plug stuff in. So 3 minus 3, just using this formula, plus 4. Well, 3 minus 3 is 0. The square root of 0 is 0. 0 plus 4 is 4. So my first point is 3, 4. So now we're going to plug in a 7. And I kind of made it nice for you. 7 minus 3 plus 4. 7 minus 3 is 4. The square root of 4 is 2. 2 plus 4 is 6. So these are my 2 points. Now, having said that, could you have come over to the dumb machine and said, Mr. Dumb Machine, I don't need your help. Please help me. We go control radical x minus 3 plus 4. Press enter. Go to the table, control T, and go find 4. What was the first point? 3. 3, there's the point 3, 4. We got that. And then we go down to 7. There's 7, 6, 7, 6. So you could do that. I don't know if that's behind my head or not. I should probably shrink this a little bit. You can go into the table and look at the table. There's 3, 4, and there's 7, 6, and those are the points we came up with. But now we have to find the average rate of change, so we just have to do slope. All you got to remember is you got to go in the same directions. 3 to 4, 6 to 4, 7 to 3. So 6 minus 4 over 7 minus 3. I usually use parentheses when they're negatives. And when they're not, I get a little lazy. So this is 2 over 4, which is 1/2. So the average rate of change on this interval, the average rate of change is 1/2. Done. All right, so during which interval does the average rate of change the greatest? So we've seen this picture before. No, we've seen something similar to this. So what is the average rate of change from here to here? Because that's the first interval, from -4 to -2. Well, it's just the slope of that line, which is 0. This interval from -2 to 2, it's the slope of that line right there. That's the average rate of change. Now, what you're not going to know until maybe you get into pre-calculus is, when we talk about rates of change, is if I take the slope of any 2 points here, they got a slope there, I got a slope there, I got a slope there, I got to go slope there, I got a slope there, slope there. There's something called instantaneous rate of change. In other words, at every single point, what's the rate of change? That's calculus. That's 2 years from now. Maybe they do it a little bit in pre-calculus. For us, we just want the average rate of change, and the average rate of change will always be the slope between the 2 points. So if I look at that, the slope between these 2 points is up 1 over 2. So this is 1/2. So the slope of that would be 1/2. Let me shrink up a little bit. So for -4 to 2, -4 to -2, the slope equals 0. From -2 to 2, the slope equals 1/2. And then from 2 to 4, my slope is negative 1. So which one has the greatest average rate of change? Whichever one has the biggest number. There it is. I actually had a kid on my last test tell me the 1/2 was smaller than, or was bigger than 1. That wasn't good. All right, so here's what we got. From negative 2 to negative 1. These are my x values. So I need to know what is the point at negative 2 comma something and negative 1 comma something. So I'm going to go to negative 2 comma, there it is. So that's negative 2, 2. And then I go to negative 1, 1. And I'll find the slope. Change in y's, 2 minus 1. Over change in x's. Go in the same direction. And these are negative, so I'm going to put them in parentheses. Minus negative 2. Well, this turns out to be 1 over negative 2 plus 2 is also 1 equals 1. Now, some of you are just screaming at me going, didn't you just say it's the slope between these two lines? Well, isn't the slope between those 2 points? I mean, it's slope between 2 points. Isn't the slope between those 2 points just 1? Absolutely. Nice work. I think we're done. Nope. All right, so this will be quick. We'll just do this last page. I think this might be it. Is this a function? Yes. Is it a one-to-one function? Yes. Domain. Let's see. It's starting at negative 2 and it's going forever and ever to the right. Range. Starting at negative 8 and it's going up forever and ever and ever. Where is it increasing? Remember, read left to right. So it's always increasing. Where does it start? It starts at negative 2. Remember, we only give y values for range and min and max, y values. Those are the only times. So from negative 2 to infinity, never include the endpoints. Where is it decreasing? Never decreasing. Minimum. Now we're going to use y values. The minimum y value is negative 8. What's the maximum y value? Well, it's going up forever and ever and ever, so the maximum y value is infinity. All right, what transformations occurred? So we moved where? Translation, well, let's see. It looks like, now, let's see. There's no reflection, but normally we go over 1 and up 1, but we went up to 2, so we have a dilation factor 2. We translated left 2, left 2, and down 8. So we should be able to write the function because that's all we need. Remember, when we start with a function, it's usually just the square root of x. Now, we could put a 2 here, but we don't need it. So we had a dilation factor 2. We put that in the front. We moved to the left 2, so that's plus 2 on the inside, and down 8, so minus 8 on the outside. All right, almost done. Domain, left and right forever. Negative infinity to positive infinity. Range, negative infinity to positive infinity. What is the x-intercept? Oh, it's right here. It's negative 5. Y-intercept looks like it's positive 5. Where is this graph increasing? Now, this is tricky. If I read left to right, it's going up, 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 going up. It's always going up. Now, don't go, oh, you're going left here. No, remember, we're starting way over here, and we're going up, up, up. So this thing is always increasing. So from negative infinity to positive infinity. This says, where is y negative? Remember, negative is below the x-axis. It's negative from negative infinity all the way up to 5. At 5, it becomes positive, or negative 5. We can't include the negative 5 because there's no equal sign. A lot of you messed that up on the test. This one over here that's behind my head, let me bring it up, is the one that says, where is y positive? Positive says, where is it above the x-axis? Where is it above the x-axis? Well, it starts becoming above the x-axis here at negative 5 going to the right. So from negative 5 to infinity. Where does it equal 0? At negative 5. Is it a one-to-one function? Yes. Therefore, the inverse is going to be a function. We're going to do two more, but if you got it, you can stop now and just kind of go get the homework done. These are just extras. All right, kiddos, these last two are just a little extra. If you got it, you got it. If you don't, come on, let's talk. Is this a function? Yes, it passes the vertical line test. Is it a one-to-one function? Of course, yes, it passes the horizontal and vertical line test. Domain, what's the leftmost number? Well, that would be right here. That would be 0, and we include it. And it goes forever and ever to the right, so it goes to positive infinity. Now, the highest number is 2, and the lowest number goes to negative infinity. Remember, when you do range, lowest goes on left, highest goes on right. Please, never put negative infinity on the right. It's just kind of embarrassing. Don't worry, we all do it once in a while. The x-intercept is right here at 4. The y-intercept is right here at 2. As we look at this graph from left to right, is it ever increasing? Does it ever go up at all? I don't think it does. I think it goes down, right? If you look at that graph from left to right, it's always going down. So where is it increasing? It's not. So we put empty brackets. It's like 2 ears, no brain, empty. Never mind. Where is it decreasing? Well, it's always decreasing, but that doesn't mean negative infinity to positive infinity. That means we start decreasing at 2, and we go to positive infinity. Now, why is it positive infinity? Because I want the x values. It starts decreasing here at 0, and in this direction to the right, it's decreasing, but that's going to positive infinity. Where do we use y values? Range and min and max. Those are the only times you're going to use y values. Every other time, pull the numbers off the x-axis, please. All right. Where is this graph? Negative. Negative means below the x-axis. So it's negative starting at 4, going to the right, positive infinity. We don't include it because it doesn't have an equal sign. We don't include the 4. Where is it 0? Well, at 4 it's 0. And where is it greater than 0? Greater than 0 means above the x-axis. Well, it's above the x-axis starting right here and ending here. So it starts at 2, it ends at 4. Now 4 is on the x-axis, and we can't use that because we don't have an equal to. But the 2 we can include. So you got to be careful. You got to be careful with those. Those ones are a little bit tricky. What's the smallest value on the graph? Well, it's going down forever and ever and ever. So the smallest value is negative infinity. Now we're going to use y values. What's the highest value? That's right here. That's 2. Again, y values. All right, let's go through this graph. All right, what transformation? It normally should be going up, but now it's going down. So we know that there is a reflection in the x-axis. So we're going to put a negative out front. It's not going in both directions, so I know it's a square root. I just don't know if I need a dilation. So what I do to test for a dilation is I say, okay, I'm going to go 1 to the right. Always go 1 to the right or 1 to the left, doesn't matter. And then I'm going 1 down. Now, if that went 2 down, I'd have a dilation of 2. If it went 3 down, I'd have a dilation of 3. I don't care down or up. The negative is the up or down. This went right 1, down 1. No dilation. Okay. Now, let's take a look at the center point. Normally, the starting point is at the origin, going in that direction. That's normally what we look at. Well, the center point did not move left or right at all. So nothing on the inside here because we did not move left or right at all. But we did move up 2. So we have a translation up 2. So we just put a +2 at the end. And you can always check that on the dumb machine. You can come over to say, hey, dumb machine, prove it to me. Prove it to me, man. And that's okay. Dumb machine likes to help out. So we put a negative, square root, x, and then +2 on the outside. And, oh, yeah, that's kind of like what my graph looks like. Good, good, good. Got it. All right, so this is a cube root because it's going in 2 different directions. Is it a function? Yes. Is it a one-to-one function? Yes. Passes both the vertical and horizontal line test. It goes forever and ever to the left forever and ever to the right, goes forever and ever up, forever and ever down. X-intercept, oh man, I'm sorry. This one's right here or something. Let's go with 3 point something. Yeah, I hope I don't ask you for the equation of this one because that would be possible. The y-intercept is clearly at 1. And is this graph increasing or decreasing? So start here and just see what you're doing. Going down, 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 going down. So this is decreasing. And that, kids, ends day 1. All right, rock on. Have a good one. See you. Hit the subscribe.